So today we'll be doing a coordinate proof with a right isosceles triangle. First off, we know that the first point is on the origin, so that means we don't have to worry about that one. All the ones represented by a question mark are ones that we have to solve. So first off, we have a y-coordinate missing here. But since this is the x-intercept of the triangle, the second one, we know that its y-coordinate is automatically 0. We also have one more point up here with both its x and y coordinate missing, which means that we have to find it. Now, obviously, because it's perpendicular to the x-axis, it's straight up, which means it has the same x-coordinate, making this a, and because it's the same distance as this line, which has a distance of 0 to a, making this a distance of a, which means that the distance here is also a, meaning that it has a height of a. And that's how we solve a right isosceles coordinate proof. Alright, now we're going to be doing an isosceles triangle, except this time we don't have a right angle, which means we're going to have to figure some new things out. First off, we have our origin point here, so obviously both coordinates are 0, so 0 for the origin. Next up, we have an x-intercept, so right away we can deduce that the y-coordinate is also 0. But now here's the new mechanic we have to learn, where we have a y-coordinate that's 2b times the square root of 3. Logically, we can already deduce that that means that the x-coordinate is 2b. This is because in triangles, if you have a x-coordinate, the y-coordinate is always the square root of 3 times the x-coordinate. And thus, we've solved another triangle. Alright, and finally, we're going to be simply drawing a coordinate proof from scratch. We're given our characteristics of the triangle here. So we're going to draw a right triangle JKL with legs JK and KL. So as you can see here, JK and L, and JK and KL are our legs, so our hypotenuse is JL. This means that also JK is A units long, and the leg KL is 4B units long. Alright, so first off we have to know that the leg KL is 4B units long. So if it's along the x-axis here, it's pretty simple. All we have to do is change the x-coordinate to 4b, so we have our distance. And from k to j, all we have to do is change the y-coordinate to a, so we have a distance of a along the y-axis. And fairly simple, we've already done it. We even have the origin plugged in.
Okay, so we're going to be finding the measure of all these angles, and we already have the work done. So this angle right here that's a right angle. So, and then this is 29, and we're going to be finding angle 1, angle 2, and angle 3. So for angle 1, because this handy-dandy angle is already listed, you're going to add 90 plus this angle, and that's going to equal 119, and then you're going to subtract 180 from 119, and that's going to give you 61. So angle 1 is 61. So for angle 2 and angle 3, so for angle 2 you're going to add angle 2 plus 29 equals 180, and then you're going to subtract 29, and then that's going to get you 151. And then you're going to add 151 plus the 17 that was already here, and then you're going to add that, and then you're going to subtract that by 180, and then you get 168. 180 minus 168 is this. So angle 1 is 61, angle 2 is 151, and angle 3 is 12. And that is how you find the measure of each angle in a triangle. Hi guys, so we're back and we're going to be finding the measures of each numbered angle, 1, angle 2, and angle 3. So for angle 1, you already have a right angle, so you're going to add 90 plus 48, and 48 is the measure of angle B. So you're adding the 90 plus the 48, which gives you 138, and then because a triangle it measures up to 180, you're going to add subtract 180 minus 138, which is 42, so angle 1 is equal to 42, and then, so to find angle 2, you're going to add 90 plus the 39 over here, which gives you 129, and then 180 minus 129 equals 51. And you may not think that's very helpful because there aren't any angles we need to find in this triangle, but having that is going to help us find this angle right here. So 90 plus 39 is 129. 180 minus 129 is 51. And angle 3 is going to equal 51 using the alternate interior angles theorem. So that's why angle 3 is 51. And also using the alternate interior angles theorem, angle 2 is going to be equal to 39 also. Thank you. Hi guys. Okay, so for this problem, we're going to be finding the value of x, and then we're going to find the measure of each angle. So, because this is a triangle, it adds up to 180, everybody knows that. So we're going to add 2x plus 3x plus 4x, which gives you 9x equals 180, and so x equals 20. So to find measure of x, you would plug x in. So 2 times 20 is 40, 3 times 20 is 60, and 4 times 20 is 80. So that's the measure of x.
Do you tell the measure of the, oh. Okay, here we're going to be explaining why triangles are congruent. We usually use these postulates and theorems to explain why triangles could be congruent. We use either ASA, SSS, SAS, or the theorem AAS. ASA states that two angles and their included sides of one triangle are congruent to the two angles two angles are included sides of another. So by my example, you see that ABC is congruent to DEF because you have a side, and you have an angle, and you have another side. So if you were to write that, they're congruent. SSS states that three pairs of congruent sides three pairs of corresponding sides are congruent because they all have corresponding congruent sides. SAS states that two pairs of corresponding sides and including angles are congruent through my examples right here. And then the theorem AAS shows that two pairs of corresponding angles and their non-including corresponding sides are congruent. And that's fine. Here, we're going to be doing problem number 6 to prove that triangles are congruent using either postulates SSS, ASA, AAS, or SAS. Since we know by the given that segment CE bisects angle BED, and BCE and angle ECD are right triangles, we need to prove that triangle ECB is congruent to triangle ECD. First, since we have our given, we put that as the statement of reason. After that, we prove that since angle BCE is congruent to ECD, all right angles are congruent. Step 3, we use that angle BEC is congruent to angle DEC using the definition of angle bisect. Step 4, we use that segment EC is congruent to itself using the reflexive property. After that, we have just proven that these two triangles, triangle ECB is congruent to ECB by using the ASA postulate.